All right, we're going to make the world's worst demonstration of how to make a gradient. So the little audience here is going to have to squint. So I'm going to show you how to create a 200 by 50 gradient. That means 200 pixels wide and 50 pixels tall that goes from blue on the left to purple on the right. In order to do this, you're going to need to make color functions for red, green, and blue. So like the basic setup is we're going to do build 3 image at 200 by 50, and then red function, green function, and blue function. And so let's start with the easy ones. Well, red function takes in an x and a y. Green, I'm just doing the setup. Green function takes in x and a y, and I'm just having them put out 0. We'll fix it later. And then blue function takes in an x and a y, puts out nothing. All right, so now we go and see. Blue is the easiest, trickiest, but maybe easiest to start with. Okay, so let's write some check expects so we know what we're doing for each function. So the blue function on the left-hand side, that is x is 0, and y doesn't matter. So pick something for y, should be 255. You can see that because when you colorize blue, the blue coordinate is 255. And then I'm going to make these all in one line just because it looks better for this particular case. Okay, and then the right-hand side is x is 200. And the y, I'm just going to leave at 30. And the answer then should be 240 because that's how much blue there is in purple. Does that look okay to you so far? Makes sense? All right. So that means I'm going to need to write the equation of a line that goes through, only the x is changing. The x is causing the change. So in this case, the equation of the line is going to be blue equals something times x plus something else. And then you see that, well, you can get your line solver if you want, but I see when x is 0, y is 255. So the b is 255. And then the change is 255 down to 140. So the slope is negative 15 over 200. And bracket will let you type fractions like that. So there we go. That's the formula. So plus 255 times negative 15 over 200 by x. And like I said, you could definitely use a line solver for that. Question? Yes. Oh, so bracket, if you don't put any spaces around the slash, it will make a fraction for you. So let's double check and make sure this can work. Well, of course, the whole thing. Okay, I wasn't really expecting that to work. Both tests passed, but it's an error. Build 3, if you get an error, try to read it. Build 3 image, expected 5th argument to return an integer in the range 0 to 255. It's 1, 2, 3, 4. The 5th argument is the function that I just wrote. Okay, what is wrong with this function? It is not an integer. Not giving an integer. It's giving a fraction for most of the values. So we need to make it an integer. You could make it an integer by round or floor or ceiling or real to int. So you pick your method. Do any of you care? I'm going to use real to int because that's what the book uses. But rounding is just fine. Okay, so now that should work. I mean, I'm not saying this produces the gradient that I wanted it to, but it does. The blue is correct. Now we have to get the red and the green correct. And you should use the same method. All of this gradient stuff is really an excuse for us to do check expects, from my point of view. So check expect, green function. Well, on the left-hand side, x is 0. Again, y doesn't matter, so pick some number for y. And oh, look, it's supposed to, the green on the left is 0. That's not so bad. How about the green on the right? That means x is 200. And on the right, the y, the amount of green is, is 32. All right, so Does that make sense? Then you go to your favorite line solver. Well, in this case, the y-intercept is 0. So this one is going to be particularly easy to write. It says 32 over 200 times x. Boom. And then you go to your red function, and it's the same. Red function 0, 15. Red is supposed to be 0. Red function 215 is supposed to give 160. Again, we get the slope. No 0 for y-intercept, so 160 divided by 200 times x. Oh, I forgot to do the real to int. Fortunately, I remembered before we ran it again. You might wish that real to int was built in. Oh well. So there we got the red function, the green function, the blue function, and then at the bottom I've got my build image. Since I think I did this right, I'm expecting all the checks to pass. Hey, how about that? Are there any questions, anything I should make sure to address before people go and try to do some more gradients? Yes, L. So so which particular number should I explain? Aha. So in the picture, you see this picture, the y coordinate does not matter. You see that the picture is vertically is the same. All of the points with the same with no matter what the y coordinate is, they have the same color. So because of that, I'm just putting random numbers for y. But on the other, like in a different setup, you might have the x coordinate not mattering. And so you have to put in random number for x. And the reason I didn't just leave it 0 is good to have some variety to make sure, to demonstrate that the x is 0 isn't the part that matters.
Okay. And what about the 200?
The 200, all of these 200s come from me writing checks on the right-hand side of the gradient. So that's from me saying a 200 by 50 gradient. So if I were a better programmer, I'd say define width to be 200, and then I would go through this. Oh, well, you see, then that would cause me to have to make all of these into fractions where I did divided by this width and change this number to width. But I think that's going to work, like if you're, well, hey, just for amusement, I will do that. So we'll go through and we'll change all of the 200s to be width because that's what they represent. But that means I can't use the special fraction notation anymore. I have to paste in like specific numbers. Well, see, in the blue one, the y-intercept wasn't 0. Like all these other ones, they do have line equations. Green equals 32 over 200 times x plus 0. And the red one, red equals 160 over 200 times x plus 0. So it was just that the slope was easy enough that I could do it in my head. I mean, since you can type fractions into Racket, there really wasn't much work in finding the slope for those. All right, so I think we got it. And I put the width there. So let's see if when we change the width to 1,000, then my program still works. Oh, hey, that was very satisfying. I think this is a good place to stop.